Jupiter does not have a dark side, at least not in the way the Moon does. There is no hidden hemisphere permanently turned away from the Sun, no forbidden landscape waiting beyond the horizon, and no unseen world concealed on the far side of the planet. But if you were to fall into Jupiter tonight, there is a point where every definition you have ever learned about planets would simply stop making sense. There would be no ground waiting beneath the clouds, no mountains hidden below the storms, and no horizon separating sky from world. According to everything NASA has learned over the last decade, there may never be one. For most of modern astronomy, Jupiter was one of the safest objects in planetary science. It was the largest planet in the solar system, the king of planets, a giant ball of gas surrounded by moons and crowned by a storm so large it could swallow Earth whole. Scientists believed they understood it remarkably well. In many ways, Jupiter was not a mystery at all. It was the answer. For decades, astronomers used Jupiter as the reference point for understanding how giant planets form, how planetary systems evolve, and why our own solar system survived its violent beginnings. The story appeared straightforward. Roughly 4.5 billion years ago, a rocky core formed inside the disk of gas and dust surrounding the young Sun. As that core grew larger, its gravity became strong enough to capture enormous amounts of hydrogen and helium, until it eventually transformed into the giant world we know today. Different from Earth, certainly, but built according to the same rules. For decades, that picture survived almost untouched. Then NASA sent a spacecraft designed to do something no mission had ever attempted before. Not photograph Jupiter, not fly past it, but look inside it. There was only one problem. Nobody had ever looked beneath the clouds. When Juno arrived at Jupiter in 2016, it carried instruments capable of measuring tiny variations in the planet's gravitational field. Those measurements allowed scientists to map how mass was distributed deep below the cloud tops, and for the first time in human history, to look inside the largest planet in the solar system. What Juno found made no sense. Jupiter was supposed to have a heart, a dense core of rock and metal sitting at the center of everything above it. The entire model depended on it. Instead, Juno found something that looked less like a structure and more like the remains of one. The core was still there, but somehow it had been mixed into the planet itself, scattering heavy elements throughout regions where they were never supposed to be. The boundary between core and planet had started to disappear. Same planet, completely different world. Jupiter was not built the way planets are supposed to be built, and the deeper scientists looked, the stranger the picture became. One leading hypothesis suggests that a young planetary embryo may have collided with Jupiter billions of years ago, violently mixing its interior and permanently altering its structure. Others believe the core simply dissolved over time, under pressures so extreme that rock itself stopped behaving like rock. Both explanations create problems. Neither explanation solves all of them. No one agrees. And whenever science reaches that sentence, something interesting usually follows, because losing its core was only the beginning. On Earth, the distinction between atmosphere and planet is obvious. Eventually, the sky ends. Eventually, you reach the ground. On Jupiter, that boundary may not exist at all. The clouds visible from space are not the surface of the planet. They are only the beginning of an atmosphere that stretches thousands of kilometers downward into darkness as pressure rises, temperatures climb, and sunlight slowly fades from existence. And eventually, hydrogen begins doing something that sounds impossible. It becomes metal, not figuratively, literally. Deep beneath the clouds lies an ocean of liquid metallic hydrogen, hotter than molten lava and capable of carrying electrical currents through an entire planet. Scientists can reproduce those conditions on Earth only for fractions of a second. Jupiter has maintained them continuously for billions of years. And somewhere inside that metallic ocean lies an uncomfortable question. If the atmosphere slowly becomes liquid, and the liquid gradually becomes metallic, and that metallic ocean merges into the diluted remains of the core itself, where exactly does Jupiter begin, and where does it end? The deeper Juno looked, the more Jupiter seemed to reject the rules that govern every other world in the solar system. Its magnetic field is the most powerful planetary magnetic field in the solar system, creating an environment so extreme that spacecraft electronics can fail after prolonged exposure to the radiation trapped within it. For an unprotected human being, survival near some regions of Jupiter would be measured in minutes. And then there are the storms. The Great Red Spot has been raging for at least 3 centuries, and for most of that time, astronomers assumed it was little more than a shallow weather system drifting through the upper atmosphere. Juno revealed something very different. The storm extends roughly 300 to 500 kilometers below the cloud tops, meaning that the giant red vortex visible from space is only the uppermost layer of something much larger hidden beneath it. At Jupiter's poles, the spacecraft found enormous cyclones arranged in stable geometric patterns, with 8 surrounding the North Pole and 5 surrounding the South. No one predicted them. No one expected them. And scientists still debate why these storms remain stable instead of merging into a single larger system. The deeper we look into Jupiter, the less it behaves like a planet, and the more it resembles an environment entirely its own. Imagine descending into that world. Not landing, descending. The clouds close above you as the last traces of sunlight disappear behind layers of ammonia and ice. Hours pass, then days, and still you are falling. There is no coastline waiting beneath the atmosphere, no ancient landscape buried beneath the storms, and no hidden surface waiting somewhere in the darkness below. There is only pressure and heat, and an environment becoming steadily more alien with every kilometer. Eventually, the hydrogen outside your spacecraft begins behaving in ways that do not belong anywhere in human experience. It becomes metal. Your instruments stop behaving normally. Your understanding of what a planet is stops behaving normally. And somewhere in the darkness, an unsettling realization begins to emerge. You may not be approaching Jupiter's interior. You may already be inside it. For all of human history, planets were places. Worlds with horizons, worlds with landscapes, worlds you could stand on. Jupiter may belong to an entirely different category of existence. Not a world hidden beneath an atmosphere, but an atmosphere that somehow became a world. For centuries, we looked at Jupiter and saw certainty. the giant planet, the reference world, the object against which every other gas giant would be measured. Then we finally looked beneath the clouds, and the planet we believed we understood better than any other began refusing to fit inside its own definition. Maybe Jupiter is not a planet with an atmosphere. Maybe it is an atmosphere that became a planet. Science has encountered moments like this before. Sometimes the anomaly disappears, sometimes the model changes around it. Jupiter has not become smaller as we have learned more about it. It has become stranger, more difficult to define, more difficult to classify. Perhaps the darkest part of Jupiter was never hidden on the far side of the planet. Perhaps it was hidden beneath the clouds all along, waiting for us to look down.